Hello and welcome! Now this is part one of my new my new project, sorry. And you kind of got a bit of a clue on what's gonna be involved with this, seeing all these LEDs. Of course, yeah. Me and my VU scales. Now for this I'm gonna be using the LM3914. They are specially designed for bar graph arrays. You can get them in 3914, 3915 and 16. I'm not 100% sure what the difference is between them, but for what I'm trying to do, they're all basically the same. I think one of them is logarithmic though, the scale. So, anyway, first thing I'm gonna do is just... What on earth was that? The freak was that? Somebody just fell. Right, nobody fell. Everybody is fine, but I have no idea what that big loud thing was. Anyway, well, it did come from my roof. Must be, I don't know what the heck it must be, to be honest. Anyway, so let's get back to this now. I want to set this out in a way, exactly the same way as one of the hi-fis we used to have when I was a little girl. Well, just before I start, I just want to introduce you to a little bit of a something. This is basically, let me just zoom out. Whoops. Oh, I am zoomed out. Okay. This thing is basically just my soldering fan that I made. Actually, when I got back into electronics the second time after many years, I built this because I just got annoyed with the smoke, but of course as like a little first project. This is not just any soldering fan, this is kind of a bit of a fancy one with a PWM circuit on here. And yeah, the controls. Because I do need, actually comes in really useful because I do need them for it to be really slow sometimes. It's even got the lighting. So whatever I'm building is illuminated while the smoke is being blown away. Yeah, I don't think I'm ever gonna need it that fast. Not unless I'm blowing away some poison cloud that's kind of gonna, you know, kill me. In which case I'll probably, like, you know, evacuate the room, but... And I don't want it on too fast because it'll make my tea go cold. Oh, I forgot to switch my soldering iron. That'd be handy now, wouldn't it? The thing is, with me, I can be quite, I can overthink a lot when I'm doing stuff like this. When I'm doing anything really. This is one of my bad traits, is I overthink. And for example, way back in college when we were doing electronics, I used to have this classmate, Simon, and we both, Simon and I, we would be known amongst the class and amongst the tutors because we'd be constantly trying to build circuits, even, you know, spending our lunchtime in the electronics labs. And we would kind of both be like building whatever. He'd be building his stuff, I'd be building mine, and the technician would just be there, and we just got this reputation of just completely being, you know, electronics geeks. But the thing is, with size work, he would actually, he would be so scruffy with his electronics. He would just like slap them on the board, just solder them quick, do everything, just completely rushing. And you know, the complete opposite to me, which is I would spend so much time on making things neat and tidy, just like I'm doing now. I'm taking so long on just soldering 4 LEDs on here that I'm, you know, having to edit stuff out just so it won't be boring for my viewers. So, yeah, the freaking stupid helping hand. It just keeps coming out. Anyway, yeah, where was I? He would completely build this scruffy stuff, but and thing is, even though size was scruffy and mine was all neat, he would always manage to get his working. So there was always some stupid little fault in mine. And this not only baffled me, but it also baffled some of the tutors. Well, one of the tutors who used to kind of come check up on what we're doing every now and then, which is nice. But yeah, it baffled him, but I think it's because he would just like slap it on with, I would just be overthinking, and with overthinking there starts becoming, you know, more problems. So it's sort of, but the thing is, we always used to work on assignments together, on certain assignments that we could, we'd work together because, yeah, we'd have different sort of mindsets, but that was good because we never used to fight or argue or anything like this. It was always, we would listen to the other one's side, which is kind of good. I respect that. I respect it when, you know, even two people that are completely different can actually, you know, listen to each other's sides and listen to each other's perspectives. You know, I respect that a lot. I just want to make sure the polarity is fine on all of them because I don't want it to be all higgledy-piggledy because it's just be extra freaking work. I keep threatening to show my my big project, my big view project, which took me months. Naturally, it would take me freaking months because of me being so pedantic, but also there's like things went wrong and it was a big complicated project. This is basically, to be honest, this project is simple. It's fiddly, but it's simple. And then again, electronics is by nature fiddly. It's not. I think you know exactly where I'm going with this one. Yes. You guessed it. You see now, this is the exact same cassette recorder we used to have when I was little. It was the main family one. And when I zoom in there, you see the VU scale layout is exactly what I'm trying to create now. And now you know one of the reasons why I have such an affection for the Marantz amplifier, because it's got the same VU scale layout. Nostalgia. It works in strange ways. So where I'm gonna go now with this is I want there to be a common ground at the bottom, so I'm gonna have to cut the tracks. How I've done this, I've put all the negative terminals, and then I will just like do metric board style, you know, solder it across all the rungs. So yeah, right. Basically, just in case anybody is building this with me, in that case it's very sweet that you're building it with me, but I don't want you to get it wrong. So I actually messed up here. When I said I wanted a common ground all the way across the board, I meant plus volts. I didn't look at the circuit diagram or that part of the circuit diagram. I assumed that it was common ground. It's not. Basically, instead of connecting the negative of the LEDs to the strip which I'm going to make all the way across, connect the positives of the LED on that strip, all as one common thing. I later realized that I've made this mistake, and you will notice this later on in the video. And I have to take out all the LEDs and reverse the polarity of every single one of them. If you're doing it, I want to spare you that all that trouble. Now let's look at the circuit diagram. I'm so sorry that it's hand-drawn and not with a... I do not have electronic simulator software. But anyway, bear with me. Okay, one important thing is, probably the most important thing, between pins 4 and 5, there is a capacitor C3. Make sure you solder that right flush next to the IC. Do not solder it far away, because for some reason it just will not work. The circuit will not work. And I had that issue the last time, and I was wondering, it was doing my head in, why is this not working? It's because of that. That was the reason. And another thing you'll notice is that this circuit has a 7806 regulator, because this circuit requires 2 power supplies, 2 plus volts, plus 12 and plus 5 or 4.5 or 6 in this case, depending on which LEDs you're using. If you're going to use this on an AC adapter, you're going to have to include the regulator. If you're going to use up batteries, I've omitted the regulator because it will take up too much power. It will drain the batteries. So there's another way of doing it with batteries. I will explain later on in the video. So cut 2, miss 1. Cut 2, miss 1. Oh man, I'm staring at this strip board and all these little dots and focusing on it so much that it's turning into one of those magic eye pictures. I can start to see an optical illusion in this strip board. Right, so I've managed to trim the board, the Vero board, or the strip board, and I've pushed terminal pins in. I haven't soldered them yet, but I've pushed them in on all the... For the casing on this, I'm going to use balsa wood. The reason why is because I'm really bad with woodwork or anything like that. First of all, I don't even have the equipment. Secondly, if I did, I'd be really bad at it. I mean, metal work, forget it completely, because I don't have the equipment and I don't know how to have the skills. That's the thing with me. When I build something like this, I'm like forever testing it every so often. I don't know why, I seem to... My all-time favorite. Just like I've never gone, I knew the sun. Young girl with eyes like the desert. It all seems like yesterday, not far away. Very soon, hopefully, I'll be playing these songs through this thing. These LEDs will hear it all. días, esa niña, señorita más fina. Should I have sense to know, like a train you'd come, and I'd lose my place. Now on this trip, I took a fall from brave, nowhere to run. Okay, so there we go. He looks like a little smiley thing. Okay, sorry, I got silly and... No, I'm not gonna apologize. This is who I am. Okay. Right, so... It's just a giant smile on legs. Right, so basically I'm gonna put the chip inside here. No, it's... Where's that probe going? Okay. No other pointing device. So that's pin 1 to 9 and 10 to 18. Now the LEDs connect to 10 to 18 plus 19, so it's like 10 LEDs you can fit on there. So if you do pin 1 is the 10th LED, but I'm not even going to do 10, I'm going to do 6 on each side. So it's going to be like this. Like that. And closer in together, make it more snuggly and warm. So yeah. 10 to 16, 10 to 16. And that's it, and the terminal pins will be there and be very useful, and everybody will be happy, and yeah, it will work. Positive thinking. Basically, Ellie, I just checked the datasheet because when I said that, I felt the conflict in my mind. So, pin 1 is the first LED, and then LED 2 is pin 18, LED 3 is pin 17 and 16 and so forth. It was just confusing because that's not going in the order that it should, but yeah, that's how it is. Get in there. Okay. Need more. Three. Stupid data sheet better be right. I've completely forgotten. It's been a little while since I did this. This pin is stupid. Okay. Okay. Why are all these stupid pins bent? No, I have not bent them. I'm not that strong. Running out of solder on this reel. There you go. Ran out of it. Oh, I'm out of solder. What do we do now? It's a good freaking job I've got more. I saw it cheap somewhere back then, so I managed to get more. Okay, that is done. Now then, put this capacitor close to the IC chip as possible, because the first time, sorry, I built this thing, I could not get it working whatsoever. And I put this capacitor way, you know, somewhere around here. And I followed the circuit exactly, and I was just like, why is it not working? Why is it not working? Da, 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 da. But then I realized that it's because this is not close to the chip, so it really affects it. Right, so pins 6 and 7 join each other. 1, 2, 3, 4, 5, 6, and 7. Okay. Unfortunately, the only variable resistors I have are these huge things, which I took out of an old TV. This is why they're huge. I mean, it's either this, and these, as you can see, have got terminals coming out of them, or it's these, and these things have got freaking pipes coming out of them. So, and it's like a no-brainer. It's gonna have to be these. Both of these I took out of a really old, desoldered out of a really old TV set. So yeah, it's just no freaking point. Man, this is a hardcore nail file. It's actually supposed to be a nail file, but it's too harsh for my nails. It's too harsh for my nails. It's freaking... You can sand down metal with it. Pin 9 is actually... Pin 9 on this chip is actually a mode changer. So it can be a bar mode, bar mode, or a dot mode. So having a dot mode would be pretty cool. So let's do it. Let's get a dot mode. I'm gonna have to put an extra switch on my circuit, but that's okay. Side of it, that is, we've done on one side. Just need to do the same thing again for the next channel. First thing I'm gonna do is Mr. Smiley Walk is going to be added to so let's get these terminal pins prepped, and should be fine, and we'll test this thing. So terminal pin, terminal pin, terminal pin, where are you? There you are. Okay, terminal pin is here, so let's kind of put this there, put in here. And why is this terminal pin so stupidly flat? From all the freaking terminal pins inside here, why do I have to choose one that is so warped? Just my freaking neck. Okay, this one's a nicer one. No, I put it in the one next to the one I wanted to put it in. For frick's sake, it's okay. One, I don't need to make it that compact. If I make it too compact, there's no point. It's not like this board is gonna shrink if I make it too compact. It's like that's how I'm treating it. Ground connected, and Smiley Dude has got one shoe on. The next shoe is, you know, being put on. Okay, so we test this. Okay, so you have this, and you have that. It goes there, and one here, and one there, and one there. Because what I do is just, I make spots first on this thing, and then I slowly join every alternative spot together. Right, I will go through that again with this little part. What I do, a little bit of flux onto the terminal pins, like that. Now, I make spots first. Oops. There. Spots first, and then join the first two. Okay, miss one, join the second two. and if it was that one there, I'd miss one, join another two, miss one, join, you know. But then what I do is, this has got the chance to cool now. This had the chance to cool now, so I just join this with this. Yep, and then join that with that. Simple. I love working with matrix board, and there we have it. That is, oh, hold on. Join this to the terminal pill. Terminal pin. Join this to the terminal pin. Okay, right, so this is positive, going to pin 3. yeah, that's pin 3. Positive going to pin 3. And negative going to pin 2, going to pin 4, and then going all the way to the negative, which is going, you know, to the LEDs. I desoldered all the LEDs and swapped them around, basically changed their polarity. Because I assumed that this was common ground. It's not. It's supposed to be plus volts going to all the LEDs. And the ground to, which is weird, to be honest. You look at a normal circuit, I mean, maybe it's just me or I don't have enough experience. You look at a circuit, the common thing between all of them is the ground, and what should be coming out from the chip is power going in, you know, like the plus volts, you know, to the LEDs. But it's not. It's the reverse thing. I find it really odd that this instead of being a common ground, this is plus volts. It's like a common plus volts between all the LEDs, and what's coming out of the chip is like, you know, negative. You're kind of, it's weird. It's just, maybe it's me, I don't have enough experience. I'm just always used to doing the common ground thing and then doing everything, you know. Anyway, I've corrected it, and it's sort of, yeah. I'm gonna edit a note in at the beginning for this too, just in case any of you are being really sweet and following me while and building the circuit with me. I don't want to make you do it wrong. just in case. I'm not intending this to be a tutorial or anything, but just a project of mine. Anyway, everything is sorted now. Everything is, and I've tested it. Now, putting this aside just for a second. Oh yeah, actually, don't put it aside just for a second. One little thing I forgot. This circuit requires 2 voltages, 2 plus volts. So there's one common ground and there's 2 plus volts. Plus 12 volts here, which powers the IC, and plus 5 volts, which runs the 5 volts or, you know, 3 volts, or that runs the LEDs. Now, if I was making this out of being powered by the mains or anything like this, this is only going to be battery powered. If I was going to do it with the mains, or an adapter I should say, not mains, then I would have, in my circuit I would have included the 7506 regulator, which regulates it down to 5 volts, and the 5 volt regulator, I mean, in this circuit, because that would provide the LEDs with a stable voltage. But we're not doing that. I'm doing it by battery. So how would I get a double voltage with battery? Simple. You see my battery holder with all my beautiful any loop batteries. I don't know what is it with me and these things. I think it's the colors, but also the fact that these are amazing batteries. They retain their charge. This is, it's got 6 batteries, therefore 9 volts. Now, with these, but if just in case you don't know, with these battery clips, you have these points here. Now, common ground, if you were to connect it, if you were to put your meter here with ground, you would get just this one battery working, which would be, you know, 1.5 or 1.2 volts in this case. If you put your meter here, you get 3 volts, just these 2 batteries. put your meter here, which is where I've done it, you get 4.5 volts because of those 3. And 6 volts because of those 4. 7.5 because of the 5 batteries. And finally 9 volts, which is here, but it's this anyway. So yeah, I just put my 4.5 volts. I soldered a wire there. So this is my second plus volts. With this circuit, make sure you connect both the plus volts first. Do not just leave one out. Why? Because this IC here, I wondered why it wasn't working because I actually forgot to connect this. So you will need, as a switch, you will need a double pole switch to kind of, you know, you double pole switch to switch both of these on. Or if you want to do it a weird, dirty way, is just to put a single pole switch on the common ground, which is, you know, you're not supposed to do that, but you can. Anyway, yeah, so what happened is this IC got red hot, and I touched it and I got seriously burned. You can see that blister there. I got seriously burned. And yeah, that was nasty. It's one of those where I'm like, I'm appreciating every single tiny bit of coldness that I can get, you know. And it's like, no, I don't have a fancy signal generator or anything like this. So I'm just doing this the best I can. That at pin 5. It's working. However, it can work better than this. And this is by half rectifying or rectifying the input by sticking a diode there. Ugh. Okay. And if you stick a diode here, can you see that's working better now? It's working way better. It needs more volume, more gain, sorry, because obviously the diode takes away some voltage, but this is rectified. It's more of a cleaner signal. Basically the difference is the LEDs with the diode, the rectified, the LEDs are staying on and staying at the same brightness as they're going up and down the scale. But without being rectified, the LEDs are changing their brightness as they're doing that. If you see what I mean. Now that, for me, that makes a big difference. I prefer with the diode, because that's how it's supposed to be. How it is on all the other VU meters. So anyway, everything is working perfect. Thank goodness. I made a mistake and I corrected it. And the next part of the circuit, I will build that tomorrow. Because right now, it's 4 AM and I need to get some freaking sleep. And yeah. The next time you see me will be in the next video, which will have, hopefully I will start making the amplifier stage. And I will do it on here as well. So yeah, thank you so much for joining me. Please subscribe for more, comment, share your thoughts, and like for support. Thank you so much. Have a good night, or a good day, wherever you're doing. I need to have a good night now, because I'm tired, as you can hear in my voice. Take care. Adios, ma'as salam.